Okay, good morning. So let's start the class. So today we will continue our discussion on logic. So I hope you still remember what is a proposition. So let me ask. So what is a proposition? Do you still remember? Okay, so a proposition is what? It's a sentence or it's a statement, and then it has a truth value, either true or false, but it cannot be both. Okay, so if you have taken some time to look at the assignment 1, then you will find that there are indeed some sentences that can be both true or false, or that can be neither true or false. Okay, so we will later talk about this in the tutorial. But basically, a proposition is a special kind of sentences where it can only be true or false, but not both. Okay, and today we are going to talk about some related topic. So you will see that this is the key thing that we are going to talk about. The propositional function is nothing very special, but we will look at it. But first of all, I will also describe the word predicate to you. So take a look at this example. So in a lot of mathematical statement, so you will see some variable like x here. So here it says x is greater than 0. Okay, but if you notice that this one is not a proposition, we have explained this already, because we don't know the value of x. So it turns out that x is a variable. If x has a value of 1, then in that case, this is true. But if x has a value like -1, then in that case, this is false. We don't know x, so we have no idea whether this is true or false, and then it is not a proposition. Is that okay? But on the other hand, okay, this is still a mathematical sentence that we will see a lot of times, and then this is talking about x. So here, x is the subject of this sentence. So we call x is the subject of this sentence. And apart from the subject, everything that is describing x, we will call it the predicate. So this is the meaning. So predicate is some property that is associated with this variable x. Is that okay? Okay, now take a look at a more complicated sentence. So here, we are saying x is equal to y plus 3, and then there are two variables here. It turns out that we will treat both x and y to be the subject of this sentence. So these are both subject or subject. And all the remaining part, so this part, they are describing the properties about this x and y, and then this is the predicate. Is that okay? So predicate, you can think of it as properties about the subject. Okay, now, what's so special about this thing? So if you still recall, so for instance, I have a proposition 1 plus 1 is equal to 3. So this is a proposition, okay? And it turns out that it is false. We can use a variable to represent it so that we can save some time of writing. So maybe we call this a proposition S, whatever. So whenever I call S, then I'm saying that this is the proposition that we are looking at. And then the truth value of S is false. Is that okay? Now, similarly for this one, okay, if you look at this one, we can say that whenever we fix the value of x, when we fix the value of x, then it will become a proposition. Okay? So it is like a proposition, only that the value of x is not fixed. But if we fix it, then it is a proposition. Is that okay? So somehow we can represent it by some variable. Let's call it p. Whenever I call p, then I'm referring this. But then I should also specify that p is based on x. So if you tell me the value of x, okay, so here, look at it. So x is a variable. Is it okay? So I can use p of x to represent this bunch of things. Okay, in that sense, okay, whenever I write px, then I mean this. Okay, and also it is very convenient. So I can even write P1. So what is meant by P1? If Px represents this one, then P1 represents the sentence 1 is greater than 0. Is that okay? So I can also write P minus 2. So P minus 2 is representing another sentence, and that sentence will be minus 2 greater than 0. Is that okay? So far so good, right? Okay, so the good thing is that if this x value is fixed, let's say it is fixed as 1, then it becomes a proposition. We know that it is true in this case. If x is fixed as another value, let's say this is minus 2 here, we know that the sentence we are talking about will be minus 2 is greater than x, is greater than 0, and then it turns out to be false. Okay? So here, this Px is very interesting. As soon as we fix the value of x, it becomes a proposition. So feed the value of x as an input, and then we generate a proposition as an output. Okay? So this is the concept of a function. So function is something that gets something as an input and produces some output. This is called a function. Function is a transformation, whatever. In English, you transform something into something. You transform a person into a frog. Okay, so this is a function. Is that okay? So magic is a kind of a function. Okay? So here, this is also a function. But this function is special. This function always transforms an input into a proposition. So you give some input to this x, and suddenly you are talking about a proposition in the end. Is that okay? So we will call it a propositional function. Is that okay? Is that okay? So a very simple concept, but you understand that, okay, then whenever x and the value of x is fixed, then it becomes a proposition. So that's why we call it a function, and that's why we call it a propositional function, because it generates proposition. Okay. Now similarly for this one, this is very, very complicated, right? This is x is equal to y plus 3. So we will see that there are two variables. So you can imagine that this is a sentence, but then we will need to fix the value of x and fix the value of y before it becomes a proposition. So we can denote this as some q to represent it, and then x and y. Is that okay? Okay, is that okay? So in that case, we can talk about what is q10, we can talk about what is q11, and so on and so forth. So for each particular, like q10, so what does it mean? q10 means that I'm substituting x with 1 and substituting y with 0 to get something. The thing that we get is a proposition. 1 is equal to 0 plus 3. Okay, so this is what is meant by q10. And similarly, q11 says 1 is equal to 1 plus 3. Is that okay? That's it. Okay, so this qxy is a function. Whenever you tell me the value of x, the value of y, I will give you a proposition. So this is another propositional function. Okay, that's it. So this is the first concept that I hope you can get it from today. Okay. Now why do we want to have propositional function? The reason is that it can generate proposition so that it can extend our language of talking about things. So we have now new ways to get new propositions. So we may first get a propositional function and then substitute x and y inside it, and then I get a new one. Okay? Or you will see that, okay, so we will combine, usually we will combine a proposition with some quantifiers to create new propositions. So what are quantifiers? Okay. So first of all, in English, we have a lot of quantifiers. So first of all, I can talk about myself. I'm happy. Okay, so this is just about me. Okay, but I can talk also about that all of the class here are happy. So all is not just about a single person, me. Okay, it's about, if we look at everyone here, in the class, all of them. So this is a quantifier that tells not just a single person, but we are considering every person in the class, and we are saying that every person in this class are happy. Okay, so all is a kind of a quantifier. So any other quantifiers that we can imagine? So what is the opposite of all? None. Very good. So none is also a quantifier. So just telling that I'm not happy doesn't mean that none of us is happy, right? We need to look at every one of us here, and then we check. And then if every one of us here is not happy, then we can say none of us is happy. Okay? So are there anything in between? In between. Some. Very good. Excellent. So some. Very good. Okay, so some. So usually in English, we will have some, we will have many, right? Okay, usually many means there are many, okay? That is close to all. And some maybe is fewer than many, okay? But on the other hand, in mathematics, okay, mathematics people are like either you have everything, or you have nothing, or you have at least one, okay? At least one is usually meant by some, okay? So this is all, okay, some. Some usually, it means that greater than or equal to 1. If there is one person here happy, then we can say some of us is happy, although there's just one. Is that okay? Okay. So these are some common English words. And then in mathematics, we have a correspondence, okay? So in mathematics, we have the case about for all. So for all, you can talk about for all x. Let's say for all x. Okay, and that are. So usually we need to talk about what are the x that we should look at. For all x that are integers. So there can be a lot of different integers, okay? Then we will talk about x squared is greater than or equal to 0, okay? Is that okay? Now look at it, okay? Now at the beginning, this x squared greater than or equal to 0 is just a propositional function. A function doesn't have any value unless we fit the x inside, right? So just looking at this part, it is still not a proposition. But here, if we add this kind of quantifier there, then it suddenly changed the meaning a lot. It says that we should look at all the possible x and check whether x squared is greater than or equal to 0. If it is really the case, then it is a true proposition. Otherwise, it is false, right? So here, it is already a proposition now. You can talk about whether this is true or false. Can you see this? Can you see this? Because we are not talking about a particular x. We are looking at all the possible x that we can, and before we make a conclusion. So previously, x squared greater than or equal to 0 is not a proposition because we don't know which value of x you are talking about. We don't know at that time. But here, we still don't know, but we look at every possible x. But by doing so, we are looking at all the possible cases before we make a decision, and then this is actually what? This is actually a proposition. Is that okay? And then we can talk about whether this is true or false. So what do you think? Is it true or false? True. True. So how can you prove this? How can you prove this? So we talk about integers, right? Integers. So integers, there are three types of integers we may think about. One is positive, one is negative, and then one is 0. Okay? Okay. For 0, it is obviously true because 0 squared is equal to 0. So it is okay. Okay, so we know. Okay, so we know what? We know 0 squared is greater than or equal to 0. Okay. Now if x is a negative number, let's say -1 or -2, then this, yeah. So any negative number, the square of it becomes positive. So it is greater than or equal to 0. So we know this is true, we know this is true. And similarly, we know 1 square is greater than or equal to 0, 2 square is greater than or equal to 0, and so on and so forth. Okay, so that means that the truth value of this one is equal to the truth value of this one, and 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 so on and so forth. And it turns out that for this case, it is true and true and true. None of them is false. So we know that this is a proposition, and then the truth value will become true. Is that okay? Is that okay? So in general, we can talk about something like so in general, maybe for all x that are interesting, so we only talk about those x that we think that are interesting. So here the interesting x are integers. Then we have a propositional function px. Then this whole thing together will become this will be a proposition. Is that okay? But there are too many words to write down here for all x that are interesting. So if every time we need to write down a long sentence to represent this, then we may be very tired. So in that case, mathematicians also invent some shorthand notation so that we can write this more conveniently. So first of all, for all x, we will use this symbol. This is for all x. Okay? And then px to represent this one. But we will talk about what is so special about x. For instance, where x are integers. Okay. So this one stands for all. So this px is a propositional function, right? So for all x px, then it becomes a proposition. And then if we specify the integers, then it becomes a well-defined proposition. Is that okay? Okay, now, this is a very strange symbol. It reads, actually, it really reads for all. So for all, it reads. So what's so special about this symbol? So why do we use it as for all? Yeah, why? It looks like what? It looks like which English character? V, very good. And yes, but it's not the reason, okay? It's the opposite, upside down. So it's the upside down A. A means all, okay? So this is for all, okay? Okay. Okay, now we need to be very careful, okay? So if we are defining x based on different interesting property, the value of for all x px could be different. Okay? So for instance, let's say, so I just remove this equality. Okay. If we still consider all x that are integers, x squared greater than 0, will it be true or will it be false? False. Okay. Why is it false? Because we can pick x to be 0, and then it is not true. So you are saying that everyone here is happy, then someone is there unhappy, then you cannot say everyone is happy. Okay? So in this case, if you remove this one, it is false. Okay? But just take a look. If I add it, suppose that the x that we're interested are positive integers only. So we change our view. So previously we looked at all possible integers. In that case, the whole thing is false. But now, if I only focus on the value of x that are integers, positive integers, then in that case, we omit the case of 0. And suddenly it becomes true. Is that okay? So we are still talking about for all x px. This is still in that form. The px is this part. The for all x is still this part. Okay, for all x px. We are still talking about the same for all x px. But based on the different interesting thing that we focus on x, okay, usually this interesting thing, we call it the domain of x. Okay, domain is a strange word. Okay, but domain means home. Okay, what are the x that you should look at? The home of all possible x's that you look at. If the domain are different, then you will have usually you will have a different truth value for the whole proposition. It is a different proposition. Okay? For all x px. So every x has if we substitute all the different kinds of x into this p, then every one of them will be true. Okay, then in that case, for all x px will be true. Is that okay? So how is it possible to talk about none? Okay, none of the x will make px true. Is there a way to translate this into this mathematics statement? Okay, so let's do this. Let's do this. So let's have a proposition. Let's call this proposition px is. Let's call this proposition px is x is happy. Okay. And then suppose that the domain of x is, so what are the x's that we are interested? Domain of x is this class. So we are talking about the people in this class. Okay, the domain of x is this class, the people in this class. So we can talk about I am happy, you are happy, she's happy, and so on and so forth. Okay, so if I say for all x px, what does it mean? It means that every one of us is happy, right? Okay, I don't know whether this is true or false, but this is what I'm saying, and this is a proposition. Every one of us is happy. Okay, for all x px. Okay. Okay, let's try our understand. So how is it possible to say to write another proposition that says every one of us is not happy, or none of us is happy? None of us is happy. So none of us is happy. So yeah, and you want no? Anyone has any idea? None of us is happy. So what is meant by none of us is happy? None of us is happy is I'm not happy, you are not happy, she's not happy, every one of us is not happy, right? Everyone is not happy. Very good. Everyone. So everyone. We talk about everyone. Okay. Everyone not happy. So this is px, right? So we can negate px. Does that make sense? Does that make sense? So this is px, right? The negation of this one is x is not happy. The reason is that px and not px are always in opposite truth value. Okay? Okay, so the for all symbol is very powerful. It can represent all. It can also represent none. Okay? If we change our language a little bit. So the next one, the next quantifier that we want to talk about is sum. Okay?